We'll solve another dynamic programming problem, and it's coin change version 2. So in this version you are given some denominations of the coins. As you can see, these will be of different denominations, and you have unlimited supply of all of these, so you can use them multiple times. And you are given one amount, so you have to make that amount using different denominations of that coin, of different coins that you are given. So the question here is that you have to try all such possible combinations and return in how many ways you can make that same amount using different coins in different amounts. So let's see one concrete example. So here we are given 3 coin denominations, and let's say their values are this coin is of value 1, whatever is the unit of currency. This coin is of denomination 2, or let me write above it 1, 2 and 5. So these are 3 denominations, and let's say amount is 6. So you have to form 6, or let's take it 5, whatever LeetCode has given. And you have to form 5 using these 3 denominations 1, 2 and 5. So how we can form that? So one possibility is that you take one of the coins. You can start from beginning or end. Let's start from end. So here we have to form 5 using 3 coins. This 3 denotes that I have taken all the 3 coins, 1, 2, 3. So if you take the last coin, then what will happen? You will include that in the solution. So if you include this denomination, what will be the remaining amount? 0. Since 5 was required, you took the last coin. So you have got a sum of 5. So you have to form now 0 using the 3 coins that are left. You can use it again if you have used it once. And the second possibility is that let's find all the combinations without including the last coin. So what you will do? You have not included anything, you have just rejected this coin. So you have to form 5 using 2 coins. So here we have got 1. This is a leaf node. Now we cannot break it further. So this is one solution where you took the last coin, and that combination is 5 itself. And there are some more combinations. So what if so this branch is solved. We don't need to move further. We are done, and that is the value. Now let's solve it again. So we have to make 5 using just first 2 coins. So again with the similar logic, we don't take the last coin. So we have to make 5 using just 1 coin. And the second possibility is that we take this coin once. So what will happen? This denomination is 2. So we had to make earlier 5, now we have to make 3, since we have included 2 here. And we are again left with the same number of coins we can use again and again. So this branch is not solved yet. So we have reached till here, and this here we included 2, so we have added 2 here. When we solve it completely, we will write down the results. Now we have to make 5 using 1. So one possibility is that you don't take any coin. So 5 using none of the coins, empty list, and you include this coin. So it becomes 4 using 1 coin. So this solution is 0. You have to make 5 using empty coins. Without coins you cannot make 5. So this is 0. So this branch is useless. Now let's solve this. In this case, always the left branch will be useless if you exclude that. So let's solve only this one. Only possibility is that you take 4 ones. So you can expand it and ultimately you will get 1. So let's straight away write 1 here. So this will mean 1, 1, 1, 1, 1. So this is the branch. Next, let's solve here. We have included 2, and left one will be that we don't include the second coin, so we have to make 3 using 1, and the second would be that we include that 2. So we will be remaining with 1. Amount was 3, we added the coin 2, so left is 1, and we again have 2 values. So 2, 2, and what is the solution of this? So 1, 1, and if we subtract this value from this, it becomes minus, negative. So it's 0, this branch is useless, and this branch will be 1. You have to make 1 using 1. So this is another solution. Now we are left with this one. This branch is yet to be solved. So again, the left branch of this will be useless. We will make 3 using empty and so on. So just one solution will be there, 1, 1, 1. And here we had included 2. So 2, 1, 1, 1. So these are the 4 possible ways of creating this 5. So let's generalize this recursive relationship. So in order to find the number of ways to make amount A using C coins, or let me write C 1 to M, let's say there are M coins. This is broken down into make the same amount but take the coins till M minus 1. Here we have taken M coins. And second is that you use the last coin. So A minus whatever is the value of that C M. So you subtract that from the remaining amount and the complete coin, all the M coins. So it breaks into 2 things. So in order to find the solution, let's say we are here in a DP table. So here this denotes ith coin, and this denotes a particular amount that you have to form. And this table is, let's say, DP, and its dimension will be, this is coins, here we list the coins, here we list the amounts from 0, 1, 2, 3, 4 till amount. So in order to form this amount, one is the same amount, that is the same column, amount is in J and this is in I rows. So same amount, that is this same column, but 1 less. So this was M. So it will depend on this value and A minus, that is J minus I. So whatever is the denomination of this coin, Ci. So let's say it's 5. Then you will subtract 5 from this amount. So 1, 2, 3, 4, 5. So you will look at the same row but Ci columns left. So this is the relationship. So let's fill it. So here we have the amount, and this is 0, 1, 2, 3, 4, 5. And later we will optimize it, since in most of the DP problems we are only requiring the values in the same row when we are solving a value, and one of the rows and some values in the above rows. So we don't need the table, complete table. When we are solving here, we will be concerned with this row itself and some value, maybe 1 or 2 in the top. So we can do it with just one row space instead of the complete space. So first let's solve it using this method. So these are the amounts, and the coins are we have 1, 2 and 5, and here we are not using any coin. So if you have to make 0 amount, then there is only one possibility, that you don't take any coin. So this column is all ones. And if you don't have any coins but you have to make some positive amount more than 0, then there is no way. So these are 0. So without using any coin you cannot make 1. Similarly, without using any coin you cannot make 2 or 3 or 4. Now we start filling this table from here. So remember that in order to fill this value, we need this value plus this value minus whatever is the coin in this row. So here it's 0. So 0 plus 1 minus 1. We subtract this coin from this value amount. So 1 minus 1 is 0. So we just go one step and we see what is the value here. It's 1. So 1 plus 0 is 1. Now same thing here. 0 plus 2 minus 1. So we look this value 1, 1, 1, 1. So intuitively also you can see that if you have just 1, there is only one way to make these denominations. Here you take one coin of 1, here you take 2 coins of 1, and so on. Now let's come here. So it will be the sum of this value 1 plus 1 minus 2, this coin. So minus 2 comes here negative. So this solution is 0. So only you add this value. Here this value 1 plus 2 minus 2 is 0. So you take this value. You jump 2 steps. So if the coin denomination is 2, you jump 2 steps in that same row and take that value and take the immediate value above it. So 1 plus 1 is 2. Now let's see why this is 2. So this cell denotes that you have to form 2, which is this value, using the coins till this point. So using the coins 1 and 2. So one way is that you use 1 1. Next is that you use 2. So these are the only two possibilities. So that's why it's 2. Next 3. So 1 plus, go 2 steps left, again 2, 1 plus 2, it's 3 now. This value plus, you take 2 steps back, 2 plus 1 is 3. Now let's see why it's 3. So you have to make 4 using this same 1 and 2 coins. So 1 will be 1 1 1 1. Then we have 2 1 1. Then we have 2 2. So you see these are the 3 values, and this is exactly being captured here. Similarly here it will be 1 plus 2 3. Then 1 plus 1 minus 5 negative. So just 1, just 2, 2, 3. Since 4 minus 5 is also negative, so we are only copying the value above it. All the values are going negative. And here it will be 3 plus 5 minus 5 is 0. So we jump 5 steps back and we come here. It's 1 here. So 1 plus 3 is 4. And we return this value since we have to make this amount 5 that was given to us using all the coins, all possibilities. And already we had listed that we had these 4 possibilities: 5 2 2 1 1 1 1 1 2 1 1 1, and here you see 4. So so this is the solution. I hope you understood it. Now how we can optimize it? So what we are doing, we are solving it row wise. So we can have a loop. So we can have a space for one row, initialize it with 0 and first value with 1. Next we go here, and what we do, we add this row and whatever is the value by subtracting this denomination, we add that value. So if it's negative, we add 0. And we come here, then we see its value. So whatever was the earlier value, we add that and we take that many steps back and add that value. So in that way you can form this row and go to next row. So just keep adding values to the earlier values by jumping that many steps denoted by the coin. So we will write code for this optimized version also. First let's write the code for this simpler version where we take space of the order of amount times number of coins. So if amount is m and number of coins is n, then this is mn in terms of both time and space. So let's first write the code for this. So this is the same example I had taken. So the vector size is a 2D vector. Let's call it dp. Coins dot size plus 1. This is the number of rows, and each row is itself a vector of size amount plus 1. And let's initialize everything with 0. I equal to 0, I less than equal to coins. So make sure that we have taken 1 extra for the case of not using any coins, and here also making an amount of 0. So 1 1 is extra in row and column. So here we have added equal to, less than equal to, plus plus I, If j is equal to 0, that is amount is 0, then there is only one way, that is don't pick any coin. So in that case dpij will be 1. Else if I is 0, that is j is not 0 but I is 0, that is you are not allowed to pick any coin, then dpij will be 0. There is no way to make that amount without any coin. Else dpij, take the value exactly above it, that is dpi minus 1j plus go coins I step to the left. It may be negative. So you must have noticed that here we did not use, in this row we did not use any of these till 4, since 4 minus 5 is negative, 3 minus 5 is negative. So in all these cases the value were negative if we subtract this coin denomination from this amount. So we make that check that if that value is negative, take 0, otherwise take whatever is the value by jumping at that many steps. So if j minus coins I minus 1, since at index 0 we don't have any coin, we are placing the first coin at index 1, so we are doing I minus 1. If it's less than 0, then take 0. Else dp I, same row, j minus coins, the same thing for which we have added the check, I minus 1. So that's it. This should build a dp table, and finally we will return the last value, dp coins dot size and amount. So this works, so let's submit. And this solution is accepted. Now let's write the optimized code. So let's comment it out. So here we will just take one row, since we are needing just one row while updating any value. We need a value immediately above it. That is, this was the old value. So take the old value plus update the new value. So we don't need to store even this in extra value, since this was the old value which will be get updated. So vector int, let's call it dp again, amount plus 1 and initialize with 0. Then dp0 initialize to 1, and for so here we are doing plus equal to. That means whatever is the value, take that and add to it. So whatever was the value here, take this and add to it some value. What value? The value by jumping that many steps to the left. dp j minus c. C is the value of the coin. And that's it. Return dp amount, and let's see. It works for this case. Let's submit. And the solution is accepted. And here we are right at the top. We are at our runtime is better than 99.3% of the CPP submissions that were accepted. So for the remaining Java and Python, it's very straightforward. You can write this and this both. So let me copy both so that you are convinced that not much change is required. So first let's comment this part. And let's see if it works. So this works, and let's submit. And this is accepted. So this is the unoptimized version. So let's compare the time it takes for unoptimized and optimized. So unoptimized version is better than just 33% of the submissions. Now let's see the optimized code. So let's comment this part. And this should work. And let's submit. And let's compare. So here we are better than 100% of the Java submissions. So you see what difference it makes. Although the time complexity should remain same for both of these cases, that is amount multiplied by number of coins, but the space here is much less. But still we see that it outperforms that method in terms of time. And in Python, let's write this optimized code. So we take an empty list of size amount plus 1. First value is 1. And this solution is also accepted in Python. And if you can try that unoptimized version yourself. You are not always required to make this optimization in most of the DP problems. But I have noticed that in most of the DP problems where you are filling this two-dimensional table, you are generally bothered about the values. You are solving it row-wise, and while solving for any value, you need some values from the row above it and to the left of it. So you don't need these previous rows. So you can get rid of those in most of the cases. But that is not required. You can do away with this simpler approach as well.